Okay, so this is lesson 3.5. It's about graphing in vertex form. The nominal objective is that students will graph quadratic equations written in vertex form. In reality, there's three things we're going to have to be able to do. You're going to have to graph equations written in vertex form. You're going to have to get the equation from a graph, so write the vertex form if I give you the graph. And you're also going to have to be able to transfer from standard form to vertex form. So before we can do any of that, we have to understand what vertex form looks like. Where standard form looks like y equals ax squared plus bx plus c, vertex form is y equals a with parentheses x minus h squared plus k. And the x minus h squared plus k is nice because it gives us the vertex right away. So if you take a look at this one, we have y equals x minus 2 squared plus 1. The vertex for that is 2, 1. So in general, the vertex is h and k. Now you want to be careful with the x one, with the h, because remember in the parentheses it's x minus h, but the vertex is plus h. So you're going to have to take the opposite sign than what's in the parentheses when you find the vertex. Now how can we use this to graph? Let's take a look. Say I want to graph this equation. Y equals 2x plus 1 squared minus 4. Well, first I have to find the vertex. That's going to be based on x and h and k. Well, h is in there with the x, but remember it's opposite sign. So h is negative 1 and k is negative 4. Therefore, the vertex is at the point negative 1, negative 4. And I'll draw that on the graph now. From there is the same process I did when I did it in standard form. You go to the next x value to the right, and the next x value to the right after that. So in this case, it's 0 and then 1. So now I look at the equation. When I plug in 0, I get 0 plus 1. I'm plugging it in for x. I'm just replacing x with 0. 0 plus 1 is 1. Square that is still 1. 2 times 1 is 2. So I have 2 minus 4, and that's negative 2. Remember to do the parentheses first and then the exponent. Don't do the 2 times 1 and then square the result. It's the squared first. Now I plug in 1. Oh, I'm sorry. Now I put the point on there. 0, negative 2. Now I plug in 1. In the parentheses, I'm going to have x equals 1, so it's 1 plus 1 is 2. 2 squared is 4, times 2 is 8, but then I have to minus 4, and that is 4. So when I plug in 1, I get 4. So I put the point 1, 4 on my graph. I connect the 3 dots, and then I copy it onto the other side to make my full parabola. And that's how you graph from vertex form. Now, unlike standard form, I can look at the picture of a graph and get the equation in vertex form. I'm not going to make you translate this into the standard form. So whenever you have to write the equation, just write it in vertex form. It's pretty easy. So let's say I have a graph that looks like that. Well, the first thing I'm going to notice is where the vertex is. And in this case, the vertex is at 1, negative 1. I'm going to write down first, I want to write above that, I wrote the form for vertex form so we can remember what that looks like. That's going to be something you're going to need to have memorized. So in this case, h is 1 and k is negative 1. So I just plug those in. That gives me y equals a times x minus 1. Remember, opposite sign for the h, squared, and then minus 1. The k does not get opposite signs. Minus 1 is minus 1. So in order to have this fully completed, I need to know what a is, because there are lots of parabolas that could have that same vertex, but they could be different widths. And that's going to be what the a tells me is how wide this thing is. So what I did is, you can see I put a dot on the point 3, 1. And that's because that point is on the parabola. You could pick any point on the parabola, but it's going to be easiest to pick a point that has integers as the coordinates. So in this case, I picked 3, 1. Again, you could pick any point you wanted to as long as it's on the parabola. And 3, 1 has the x value of 3 and the y value of 1. So I know if I plug in x equals 3, y is going to equal 1. That's what the graph is telling me. So I plug those in. X is 3, y is 1. Now I have all numbers except for the letter a, and I should be able to solve for a. So in this case, 3 minus 1 is going to be 2, and then I square it, that's 4. So what I have is 1 equals 4a minus 1. I add 1 to both sides to get the negative 1 away from the a. That's going to give me 2 equals 4a, and then I divide both sides by 4. That's going to give me a equals 2 over 4, which is 1/2. So now I know the value for a. So I go back to where after I plugged in the vertex, and I replace the a with 1/2. So this becomes y equals 1/2 times x minus 1 and then squared minus 1. Okay, remember what you're doing here is you're trying to find an equation. You're not solving for x, you're not solving for y, so your answer has to be an equation. Y equals some equation with x, and it should look like the vertex form. So you shouldn't have an a, you shouldn't have an h, you shouldn't have a k. The only letters should be x and y, and you need to have both of them. The final thing we're going to do is convert from standard form to vertex form, and there are two methods to do that. I imagine you're probably going to want to do the second method, but I'm going to show you the first method anyway. So option 1, completing the square. And I told you this would come back. So what I could do is I could take 2x squared minus 4x minus 8, and I could use completing the square to come up with that x minus h squared part. So to complete the square, I first have to have x squared. The a term has to be 1. So I have to divide everything by 2 to get x squared, the x squared term, to be just x squared, not with a number in front. So I do that. Y divided by 2 is y over 2. 2x squared divided by 2 is just x squared. Negative 4x divided by 2 is negative 2. And 8 divided by 2 is 4. Okay, the other thing I do when I complete the square is I move that third term, that c term, to the other side of the equation. And so I can do that as well, just by minusing 4 on both sides. So this becomes y over 2 minus 4 equals x squared minus 2x. Now I'm going to try to complete the square on the right-hand side. In order to complete the square, you take the middle term, which is negative 2, divide by 2, which is negative 1, and then square it, which is 1. And I take that number and I add it to both sides of the equation. So now I have y over 2 minus 4 plus 1. All I changed was adding 1 to both sides. Equals x squared minus 2x plus 1. Again, the only thing I changed was adding 1 to both sides. Now on the left-hand side, I'm going to combine the negative 4 plus 1, the like terms. And on the right-hand side, I'm going to factor it. Now the whole point of completing the squares, because I knew when I divided 2 divided by 2, negative 2 divided by 2 and got negative 1, I knew that's what was going to be in the parentheses with the x, and then squared that binomial. When I combine the minus 4 plus 1, I get 3. So now I have y over 2 minus 3 equals x minus 1 squared. But I'm not done because vertex form has y all by itself on one side of the equation. So that's what I have to do. So I'm going to add 3 to both sides. That's going to give me y over 2 equals x minus 1 squared plus 3. And then I'm going to multiply everything by 2 to cancel out the divided by 2. So this is what I get when I multiply everything by 2. X minus 1 squared times 2, I just throw a 2 out in front. 3 times 2 is 6, and there's my final equation written in vertex form. So now I'm going to show you the other method of getting these into vertex form, and that's by using the formulas we used last time to graph the standard form to find the vertex and then plug in the x, the h, the k, and the a. So you'll notice that's the exact same equation. So we already know what we're going to get for an answer. We're going to get what we just got when we completed the square. And I want to show you that this method will give you the same answer as the first method. So first I have to find the x coordinate for the vertex. And that's the formula we were using extensively last time, and that's negative b over 2a. So in this case, since b is negative 4, negative b is positive 4. And since a is 2, and we get 2 times 2 on the bottom, negative b over 2a. And when I do that, I'm going to get 4 over 4. So the x-coordinate for the vertex is 1. Now I plug that back in to get the y-coordinate for the vertex. So I have 2 times 1 squared minus 4 times 1 plus 8. This is going to be 2 times 1. This is going to be 2 minus 4 plus 8. That's going to be 6. So the y-coordinate is 6. So the entire coordinates for the vertex are 1, 6, which if you remember from vertex form, the x-coordinate for the vertex is h, the y-coordinate for the vertex is k. And let me write the vertex form again. So I have a x minus h squared plus k, so if I have 1, that h is going to go where that h goes, and that k is going to go where that k goes, so all I have to figure out is where the a comes from, and thankfully, if you remember the standard form, it's ax squared plus bx plus c, so that a equals that a. So you just have to get it from the standard form equation. You don't have to do that whole thing where you plug in another number and like we did on the graph. It's much simpler this way. So I just plug in those 3 numbers. That's y equals 2. Remember the 2 came from the original standard form. X minus 1, because remember it's opposite sign when you do the vertex. squared, and then plus 6, and I'm finished. So when you have the problems on the homework, you can do either one you want. You could complete the square, or you can find the vertex. I would imagine most of you are going to want to find the vertex. It's a little less mentally challenging than completing the square, but either method you want to do, whichever seems easier to you, is what you should do. Okay, I'll see you next time, and good luck on the homework.